Let's take a closer look at proportions. Remember, a proportion is a comparison of two ratios or two rates that are equal to each other. For example, 3 is to 5 as 6 is to 10, which can be represented as the fraction 3/5 equals 6/10. Be careful. When you're presented with what looks like a proportion, you need to check to see if the two ratios or the two rates do form a proportion. Let's check to see if these are proportions. Let's use cross multiplication to check them. 2 times 9 is 18. 4 times 3 is 12. 18 does not equal 12. So this one is not a proportion. Let's try another one. 3 times 12 is 36. 9 times 4 is 36. 36 equals 36. If the cross product is equal, then the two fractions are equal, and therefore they are a proportion. Okay, let's try another one. Does 1/3 equal 2/6? 1 times 6 is 6. 2 times 3 is 6. 6 equals 6. This is definitely a proportion. One last try. 5 times 7 is 35. 4 times 8 is 32. 32 does not equal 35. So these two fractions are not equal. Therefore, they are not showing us a proportion. Here, we would like to find the value that is missing in each proportion. In order to make the two fractions represent a proportion, they must be equal. So what we will do is use cross multiplication and solve for the value of x. The value of x that makes the cross product true will also make the proportion true. 2 times 32 is 64. 16 times x is 16x. X is a missing factor, so we'll use division to solve for it. Divide both sides by 16. X equals 4. The value of x that makes this a proportion would be 4. Let's try another. 3 times 20 is 60. 4 times x is 4x. What value of x will make this equation true? Let's divide by 4. X equals 15. The value 15 makes the proportion true. Let's go for another one. 5 times 18 is 90. 15 times x is 15x. Let's divide both sides by 15. 90 divided by 15 is 6. The value of x that makes these fractions a proportion is 6. One last try. 15 times 8 is 120. 24 times x is 24x. Divide by 24, and we get x equals 5. The value we can replace x with is 5, and now we have written a proportion.